Hello. In this question, the answer is E. All statements are correct. You may understand it as excuse me. We would like to know we are curious about the probability of defective batteries among all batteries. That is what we want to know. And but we cannot observe all batteries. We cannot inspect all batteries. So we calculate the probability of defective batteries among some randomly chosen inspected batteries. So that's the structure of estimation, statistical inference. So it shows the example show what we are doing. And we are going to study the parameter and the statistic a little more carefully. It seems obvious, but yeah, it's obvious. So the parameter of interest in general is usually denoted as theta, a Greek letter theta. And like later, when you have a specific parameter, then you may use a different notation. But in this class, I'm going to use theta as a generic parameter you are interested in. And just a sudden question. What do you think is not a parameter? So there are 5 examples. Standard deviation of life expectancy, expected increase in sales after a price cut, total number of heads when you toss 10 coins, difference in mean gas prices in New York and California, and conditional probability of making a second free throw after making the first one. So there is nothing much to think about. So there is nothing much to explain more about a parameter. Parameter is just a summary measure, numerical measure about the population, and it is the target, what we want to estimate in inference. Then among these 5, what is not a parameter, or in other words, what you cannot estimate, or what is not what is an inappropriate target in estimation process. Let's think about this. The answer is C. Total number of heads when you toss 10 coins. This is not something you can estimate because it is random. It changes every time you toss 10 coins. So it is random, so you cannot estimate it. There is no right answer. When I ask you, what is the number of heads when you toss 10 coins? There is no fixed answer, so it cannot be a parameter. In other words, you may think tossing 10 coins is just one random sample, composed of 10 observations. So this is a measure about the sample, not about the population. So it cannot be a parameter. So, and in contrast, anything about the population can be a parameter, or anything you can calculate when you could repeat the experiment infinite number of times, that is a parameter. So basic idea is you are learning statistics because you cannot repeat experiments infinite number of times. So what you want to know in statistics must be something that you know when you have infinite number of observations, right? Anything like that is a parameter. So it means that your goalpost is not moving. Like in this case, clearly the target is moving around. You cannot there is no right answer. So then read the others. Standard deviation of something. Standard deviation is if you calculate it from infinite number of observations, that's the parameter. Expected increase in sales after a price cut. If you can repeat this experiment infinite number of times, then you get this. You obtain how much how much sales increase, and difference in mean gas prices in New York and California. If you observe every gas station in these two states, then you can calculate this. Conditional probability of making a second free throw after making the first. Also, when you repeat this experiment infinite number of times, you can calculate the conditional probability. So in that sense, a parameter must be fixed when you could repeat the experiment infinite number of times. But C does not satisfy that condition. Even if when you try one infinite number of times, the outcome will be different every time. So it's not a good target. It cannot be a target in your estimation. Okay, that's the parameter of interest. It's that simple. So we set our target. Parameter of interest is given, and you can think of it as the true mean or true probability. And then we have to now think about the estimator. This is more complicated because setting a target is not that difficult. That's just like declare I'm going to estimate something. The major problem is then how? How would you estimate that? That means you have to choose a good estimator, and the estimator for theta is usually denoted as theta hat. It corresponds to parameter theta, and when you put hat, it means the parameter is estimated, right? Hat means usually indicates an estimator. And so in this example, suppose that theta, the parameter of interest, is the true expected value of x, right? And theta is the expected value of x, then you may use. So suppose that we are curious about the expected outcome from a dice by throwing many dice or throwing a dice many times. Then you may use, say you observe 100 dice results. Then to estimate the true expected value of the outcome, you may use the sample average, sample mean. So you can calculate sample mean of 100 dice results. Or, this is the most natural estimator, but you may use sample median, right? It's in the end it will be correct. It will be close enough to the mean, but sample median makes not much sense. But it's not that wrong, not totally wrong. Okay, and yeah, we are going to discuss how to tell what is good and what is bad. Or you may think it's more tricky. Sample mean after deleting the minimum and the maximum, like in the Olympics. When you delete the minimum and the maximum and take the mean, then it sounds okay. Then what do we use? What is the best estimator? That is the remaining question, and a very important question. So then think about this. Now you want to estimate the mean gas price in New York City using 100 observations. Which of the following you cannot use as an estimator? So to estimate a parameter, you have to calculate a statistic. The statistic is called the estimator. You are going to guess the parameter by a number. That is a statistic or an estimator. So think about this. Any number that came to your mind, such as 10. So just whatever number that came to my mind. Is it an estimator or half of the sample average? Like I want you to estimate the mean gas price, but somehow I took half of it, half of the sample average. Is it an estimator? And third, C, sample variance. We are estimating mean, but somehow, someone is calculating the sample variance. And D, population mean. We are estimating the mean, then estimator or population mean. And finally, the gas price at the nearest gas station, or say any of the first observation you read can be your estimator. Think about this. It's a tricky question. Interesting question, and think about this. And the answer is D. D. It's like this. When I ask you A, B, C, when I ask you this question, so like this, I gave you, suppose that you get this question in an assignment. Then, even if you are wrong, you have to choose one of them. A, B, C, D, E. You have to say one of A or B or C or D or E. But if you say K, it's not in your option. That's not an option. That is not a valid answer. Like that, even if it's wrong, like so when I ask you what is the mean gas price, whatever number can be an answer. Like any number that came to your mind. Even though it's absurd, it does not make any sense, but it is a valid answer, even if it is wrong. So, similar, half of the sample average, there is no reason to take the half, but still it is a valid answer because it will be a number. Sample variance will be a number. Gas price at the nearest gas station is going to be a number. So the other four, A, B, C, E, are valid answer. It's a number. When I ask you a question, you tell me n is the number, even if it's wrong. But the problem is D, population mean. It does not make sense because what we are estimating is the population mean. When I ask you what is not an estimator, then your answer, you say non-estimator is not an estimator. It's not an answer. That's just an obvious tautology, and it is not an available number. Population mean is unknown. So I'm asking you, what is the population mean? And it cannot be an estimator. So it is not an option. If you knew this, you do not need an estimator. So that's what I want you to say. You cannot use unknown object as an estimator. So the others are obviously wrong, very likely wrong, but still they are estimators. I didn't ask you what is a good estimator, but just ask you what is an estimator. So the next topic we have to think about is then what is a good estimator? You can think of any number that you can calculate, or any number you can say is an estimator. Then how to choose a good estimator? That's what you're going to study in the next video. See you in the next video. Thank you.